Also for your H, the reflectance from the crop, you can see the similar trend there. And also for your latent energy at the end, which is then used to calculate the evapotranspiration. We used also the standard FAO equation for net radiation, and they found that it doesn't work for the Western Cape province itself, and they had to develop a new one to get better results that we can now have trust in using for future work. There you can see as well the comparison of the ET, actual calculated ET, by means of normal calculations, field work, and then the red dots are the seaball calculations. I'll just to show you this summary in the end. A lot of this seaball technology has been applied to projects all over the world, in Spain, Brazil, Turkey, and there you can see the difference between the seaball is the green, and the yellow is field measurements that have taken place in different places all over the world, and also different crops. So you can see it varies from a 0.6% difference to, in some places, up to about 7% difference in two values. There you can see also in the past, when they started with 1901, there was about between the measured and the seaball evaporative fraction, there was about a 25% increase. But as they improved the technology and the models, it is a very good correlation between field data and the seaball calculator data. I mentioned at the beginning that we did start with this in areas where we had field work. There you can see the dark blue is the ET that we calculated using the water balance methodology from our own field data that was available, and the light blue was the ones calculated with the seaball. That was the 2004-05, this was for 05-06, and for 06-07. So you can see there's a very good correlation between the field data calculated and the seaball calculation. This project and the type of applications has received various acknowledgement and interest from all over the world. You can see a summary of articles that were placed in different magazines. Now the question is, where do we go ahead with this? Well, what's the future? What we want to do is we want a fully operational system. I forgot to say at the beginning, we only operate the system during our irrigation period in the Western Cape, which is from the 1st of October until the end of April, because that's the time that the farmers need the information. It would be good to have a continuous project running for 12 months of the year, but costs limit us at this stage to do it over that winter period as well. But we want a fully operational system. We want a system that's being used by the farmers. The information must be of use, and it must be able people must be able to add value to that, and add their own value to the information that we provide. Very important, it must be affordable. At this stage, the estimate is that the cost will be in a region of about 110 Rand per hectare per season, which I think is very affordable. If you think about the input cost that you can save in terms of energy and fertilizer, all the other benefits, 110 Rand per hectare is not that expensive. We need more time for new technology to be adopted. It's a new thing for farmers to get used to. We must provide them with the information and build the trust with them, and show the complementary use of the data sets. How can value be added to the information that we already have? Thank you very much.